Hello, I'm Dennis Canton. Welcome to an introduction to HL7, a survival guide to help you take control of your data. Today's agenda over the next 30 minutes, we'll be covering what are the HL7 standards, challenges with the HL7, questions to help you and your team understand healthcare data, how to integrate and exchange data. I'll review some case studies, and then we'll wrap up with some of the available HL7 resources on our website. Who is Caristix? We are a software company who provides device and software integration solutions to the health industry. We are HL7, fire, and integration experts committed to providing best products, solutions, and services to optimize time and budgets. Caristix is present in more than 100 hospitals and health information system providers in the United States, Australia, Canada, and Europe, and more. Our solutions are integration engine agnostic and can adapt easily to your environment. We strive to adapt to your needs, from interoperability strategy consulting to turnkey implementations, deploying your product in a care environment that's cost effective. HL7 interfacing. It doesn't need to be the painful integration experience you might be familiar with as you work to connect the systems that make your environment hum along. This webinar is meant to help you get a firmer grasp on the complete set of challenges, standards, and choices you need to make along the way, whether you are developing interfaces on your own or working with a third party. Why you need an HL7 survival guide? Well, whether you're an analyst or a leader serving at a hospital or a healthcare provider organization, HL7 interfacing is likely to be top of mind. After all, it's what makes it possible for you to connect to the diverse range of systems throughout your environment for the electronic sharing and retrieval of health information. While the HL7 standard provides guidance on organizing data, you are likely trying to unravel many misconceptions about HL7 interfacing. To make matters worse, you are up against multiple interoperability issues due to meaningful use requirements, forcing data integration among numerous systems. It's no small task keeping pace with all the HL7 standard developments, issues, and best practices. In fact, you're not facing this challenge alone. According to the Frost & Sullivan, healthcare organizations' spending is $1 billion per year addressing system interoperability issues. What are the HL7 standards? The HL standards are a set of messaging standards that aim to create a consistent messaging framework to allow clinical applications to seamlessly exchange data. More than 90% of healthcare facilities and the largest health information system vendors today use this standard. HL7 is used by clinical interface specialists, healthcare application vendors, government entities, and medical informatics. There are several versions of the HL7 standard, including version 2. The HL standard allows applications, software, computer systems, and electronic medical devices produced by different manufacturers to be able to speak a common language, to carry out a transaction, and to exchange medical and administrative data on patients as they would an electronic messaging service. How it works is, by default, any HL7 health electronic device connected to a network listens for HL7 messages sent by other HL7 devices. An HL7 device that wants to send medical and administrative data to another HL7 device must do so by broadcasting its HL7 message to everyone on the network with the appropriate triggers. The recipient device, seeing the message pass, will know that it's the recipient according to the trigger code used in the HL7 message. Although this standard, HL7, is not plug and play, since the standard states in its basics that anyone can customize and deviate from the HL7 standard. This means that any integration of a new HL7 system into a healthcare network requires integration work to validate conformance to the HL7 specifications and to test its operability with others HL7 devices on the network. Version 3 is an evolution of version 2, in particular to integrate additional specifications, add new options including encapsulation, standard web documents like XML, JSON, and HTTP within the HL messages, and also support CDA, or Clinical Document Architecture, CCD, Continuity of Care Document, and SPL, Structured Product Labeling. Version 3 offers a framework aligned with the ISO 27931 standard, making it possible to better supervise, structure, and simplify the software development of HL7 implementation in the HL7 devices and software. The vast majority of HL7 software, systems, and devices found in healthcare computer networks support HL7 version 2 and support certain options and features of HL7 version 3. Word of caution, version 3 is not backward compatible with version 2. FHIR, which is an acronym for Fast Healthcare Interoperability Resources, is a fairly recent new international standard aimed at replacing HL7 in the long term for transactions and transfers of medical and administrative data between applications, software, computer systems, and electronic medical devices in the healthcare sector. FHIR is able to standardize transactions and exchanges of medical and administrative data, but using a completely different technical approach from HL7. Each FHIR device on a healthcare IT network will expose an API for solicitation by other FHIR devices. FHIR operates more in a client server interoperability mode, whereas HL7 operates by broadcasting the messages to the whole IT network. FHIR natively supports standard web file formats such as HTTP, XML, JSON, whereas these formats were amended in the HL7 version 3 specification. FHIR presents a simplified technical specification compared to HL7. FHIR is new. It's not yet mature. It's still subject to change in its specifications. A major challenge for FHIR will be the transition migration effort of the many HL7-based healthcare IT networks, an equal number of HL7 software systems and medical devices. Currently, medical device producers are beginning to add FHIR specifications into their new products. And finally, there doesn't seem to be a significant business driver in the industry to economically justify a transformation from an existing HL7 to FHIR. Example of an HL7 message. The standard defines the transactions and data exchanged are carried out in the form of HL7 messages. Each message is independent of the information it contains. The standard defines several aspects: syntax with field delimiters, types of transactions, 175 different field segments, 91 types of data strings or data type, more than 300 sets of codes or tables, and 370 trigger events and field delimiters. It's critical to approach the HL7 interface project with a clear idea of what you're up against. Here are three main challenges we routinely see. Customizable HL7 format. The HL7 version 2 standard specifies a data structure based on trigger events, segments, fields, and data types. The recommended structure must account for complex clinical workflows and data representations, so the standard allows for extensive customization even when product specifications exist. As a result of the many variances and adaptations of the HL7 standard, there's no true standard way that systems are implemented and data is handled. In other words, plug and play is not part of the vocabulary. Configurable and customizable HL7 data tables and code sets. The HL7 standard provides a recommended set of data values for transactions, but they can be customized, in fact, should be customized or configured under certain circumstances. Again, this means the data can be handled differently in each system. Some translation and data mapping would need to occur during data exchange, so each system sends and receives data it can understand. The data semantics. Good data semantics implies that the meaning or intent of the data, not simply the data value itself, is exchanged accurately. It's essential for HL7 interfaces to convey their interpretation of the standard in use, or confusion will ensue. It's the difference between NA, standing for not applicable, or no allergies. Here are questions to help your team understand healthcare data. Question 1, understand the message interface specification provided by your vendor. Hearing them say, your vendor, we are all HL7 2.4 is not enough. Ask the vendor to provide details about messages, segments, fields, the need for Z segments, etc. Also find out how they handle data semantics. In other words, what does the data mean? What is it used for? By extension, understand workflow-related information, event timing, vocabulary definitions, and who will use the information and how. Question 2, understand the type of message that will be generated based on the event. An example, a patient admission, patient visit, canceling a transfer, sending a partial lab result. Understand what data is provided with the event, including the various code sets. Number 3, how do the code sets and content evolve over time? And who will handle the updates and how? Question 4, where does the data go? Is there a need to protect sensitive data? How does the new system manage errors? What happens to messages that aren't understood by the destination system? What happens to rejected messages? We all agree that in a perfect world, no piece of information and no message would be dropped. But the reality is that it can be, and it will happen. How would users and the overall workflow be impacted in such a situation? How can you mitigate the risk? And finally, question 6, how do you handle workflow changes? If it's a matter of adapting the interface, how is this handled? How much time does it take? What does it cost and who pays? You want to avoid frozen interface syndrome, which occurs when you are trying to implement a new interface and need all the participants to switch over at the same time, but you can't get the cooperation. Worse yet is the interface black box syndrome, when you lack full visibility into all the work that's gone into the interface development, handled by a third party, making it nearly impossible to upgrade, tweak, and manage the interface without spending lots of time and money. How to integrate and exchange data. Regardless of the version you choose in interfacing, the first step is to define your healthcare integration strategy. Will you use a point-to-point architecture? Do you need an interface engine? What integration capabilities do you need? Your choice will impact the scoping of your project, so it's critical to nail down your strategy from the get-go. The key takeaway: integrating several systems will require more extensive mapping and configuration than a simple point-to-point architecture. Gap analysis, a crucial HL7 requirement document. Once you have profiles for your source and destination systems, you need to capture a list of all the gaps existing between the two systems in a requirement document. You unearth this list by conducting a gap analysis, which will tell you what's missing and what needs to be bridged by the interface. In essence, a gap analysis captures the differences in messaging between the new system and the existing IT infrastructure so the system can exchange. A good gap analysis will also document which system and who, you, the vendor, or another third party, will handle any issues. Test scenarios. Why to test, you ask? When you start to develop and iterate on your interface, you run tests to avoid introducing new problems. You check and test your code to make sure not to inject errors. This is true both during interface development or configuration and while in maintenance mode. These testing helps you determine whether or not the interface makes sense and meets your requirements. Once you're satisfied with the interface, you move to validating testing. This is when you determine if the interface will work and meet the requirements of your clinical workflow. Specifically, you test performance, extreme data cases, and how well the interface supports large volumes. By configuring this out before you go live, you'll save a lot of implementation headaches and alleviate the time clinicians need to spend helping you validate the interface once you go live. While the right test tool is helpful, you need to feed it the right message sample and test message. After all, messages impact the entire interfacing lifecycle. So what makes messages right? Namely, you need message samples and test messages that reflect your environment, your ADT message flow, your specific lab codes, and your case mix, whatever information your interface is intended to share, just as you need sample messages elsewhere in the interfacing lifecycle, for instance, scoping, you need them for testing too. As a reminder, sample messages give you custom format, structure, and data values. Process and workflow. Next, you need to map out your process and workflows to understand how your interface and support them. For example, your clinical workflow may look like this. A patient is admitted in the emergency department via the department ADT system. The doctor on duty orders lab work and the patient is admitted to the hospital. The admission is now recorded as an inpatient in the standard ADT system. The attending doctor orders medication via the hospital pharmacy system. The night nurse administers medications and records this via the barcode medication administration. Not satisfied with the patient's progress, the attending doctor orders new labs and, after receiving the results, decides to perform a procedure which requires the patient to be transferred to another location. The doctor orders and transfers are recorded in the inpatient ADT. The patient improves and discharged, and this event captures in the same ADT. Finally, thanks to the meaningful use, the patient, family doctor receive a discharge summary via the local HIE. All of these events comprise a workflow representing a patient's stay or visit. And while some workflows are optional, some always happen a certain way. What's important is knowing where the data is going and how it's going to be used. Now I'd like to share a couple of case studies of existing customers. Our first one will be Julia from Ivanix, followed by Diane at Victoria Health. Julia is a principal software test engineer at Ivanix. They are a medical technology company with the vision to eliminate infusion-related patient harm. The Ivanix infusion system is an innovative system and smart pump designed to enhance patient safety and fundamentally transform the infusion delivery. When Julia's team identified a need for a simpler solution to performing HL7 testing, Julia was tasked with finding the right software vendor to automate these tasks. There had to be a better way to test HL7 messages across multiple medical devices and systems. Searching HL7 blogs and reviewing documentation online, Julia came across Caristix. After Julia and her colleagues rigorously tested Caristix, they concluded it would be the ideal solution for their needs. The Caristix test application would automate their existing manual testing activity, saving Ivanix valuable time, all the while reducing the risk of missing some errors. Julia is confident that she and her team will keep pace with their anticipated testing requirements as Ivanix installs a new the install base grows. To fulfill the needs of her migration project, Diane Linnell, Integration Architecture and Development Manager at the Department of Health and Human Services in the state of Victoria, conducted a research to evaluate potential solutions. Identifying Caristix as a contender, she received great feedback from another state department who had also used Caristix solutions. Thanks to the ongoing support received by the Caristix customer success team, Diane came to the conclusion Caristix was the right solution for her organization to meet activity milestones and ultimately the project deadline. The Caristix tool became essential in helping Diane read, compare specifications, edit, and test HL7 messages. Caristix helped focus on the gaps that mattered to Victoria Health, resulting in an increased output of 50%. An added bonus to the project team has been the ability to easily produce and share documentation of those gaps. Next are the resources available. If you go to www.caristix.com, you'll find a library of helpful videos, white papers, and also we have HL definition, which most agree it's the best HL7 standard reference available. We have a message app, an online tool to help validate and read messages, which is available in a monthly subscription. And you'll see a new product offering, which we now offer under our services, which we have called Firify. Here are the application tools that you'll also find on our website. You can see we have various tools that would help allow you to read and interpret HL7 messages. We have our unique Cloak, which is a de-identification tool, our Test, which we talked in the Ivanix testimonial, and also Pinpoint, which search and find specific content. These are available on a subscription basis, so check our website today. In terms of resources, you can see we are a team of 5. We've got Jean-Luc, our integration architect. Our technical support and analyst is Maxime Dupont. And we've got our cybersecurity specialist, Regis, and of course, our integration engineer, Sasha, as well as myself, the business analyst. So feel free to contact us. And we'd like to make a special offer today. If you are facing an interoperability data integration challenge, contact us to schedule a 30-minute assessment on how Caristix can help you with your HL7 data integration requirements. So again, our reserve your time and spot now. You can contact me at denny.canton@caristix.com. There's a phone number as well. You can access us through our chat on our website. So please feel free to contact me with any questions that you have. I do appreciate the time today that you've taken to listen to this. This will be posted and the recorded version of this will be posted on our website. So thank you again today and wishing you a great Thursday.